Hello, wonderful people of the internet. Welcome back to another episode of Simuleos TS 715-209 Flask and Kodo. How are you guys? I hope you're all having a wonderful day. Okay, Kodo, I haven't been here in a while. How have things been? Right. Actually, how long has it been since the last time I've seen you on stream? It must have been at least a month or two. I'm really bad at keeping track of time, but I feel like it's been a while. Hey, welcome back. You came at the perfect time. We are actually just getting started. Well, we started it yesterday, but you know, we're starting it again today. Working on a new algorithm. Well, okay, an algorithm that we worked on a long time ago, but we're finally finishing up a new algorithm. You know, we're getting there. Let's see, how's the plague been for you? Coronavirus has been okay for me. I actually am quarantining down in Alabama with my family. Last time I was here, you had just gotten your PhD. Right, so that must have actually been January, right, when I was up in Boston working at MIT. So I'm still working at MIT. I'm just working remotely in Alabama, and that's kind of the only thing I have to update. So right, let's go ahead and get started. So we're going to CD into projects, Simuleos, and fractals over here. I'm going to run the last G++. Actually, let me see, what do I have here? lsstar.mp4. I have a video.mp4. I don't know what it is. It could be very embarrassing, so let's look up video.mp4, and it is exactly what I was hoping for. So today we are going to be worrying about, or we are going to be working with iterated function systems, which are ways people can generate fractals and fractal-like structures, along with a whole bunch of other things. And that's kind of, yeah, that's today's stream. That's what we're doing. So I created a terminal, stuck it behind my face, and I'm going to run mpv, I guess, projects, Simuleos, fractal video.mp4, and I'm going to loop it. Okay, so this triangle thing that you see here is a very, very famous triangle. It's a triangle that I'm sure most of you guys have seen or heard of before. It's the Sierpinski triangle. It's a triangle of triangles, of triangles, of triangles, so on and so forth. So yes, this is what we'll be generating today, and what we need to work with. It's the Legend of Zelda triangle. It's like, I mean, it's a Legend of Zelda if it's a lot of Legend of Zelda triangles put together, the Triforce. Last time I was here, you just got your PhD. Did you get a haircut? No, I did not get a haircut. I realize a lot of people have been saying I need a haircut. I understand. I'm just gonna try to grow it out, see what long hair looks like on me. I've never done long hair before. I've been wanting to do long hair since I was like 10. So it's one of those situations where I figure, hey, let's just let it go, or let it grow, I guess, because, you know, the coronavirus won't let me get a haircut anyway. So might as well just do it now. Have you been watching the streams from Stephen Wolfram? I have not, but I have heard he did some pretty spectacular things recently. So if he's still live, which he probably won't be, but if he is still live at the end of stream, I will probably raid him. If actually, Knowledge, do you know what he's been up to recently? All I've heard is that it's been spectacular. I have not heard anything beyond that. I probably should have, but he's offline now. Oh, he was just online right when I started streaming. Dang it, I'm sorry to hear that. But yeah, catch me up. What's he up to? It was some sort of theory of physics and everything, and that's not usually up Wolfram's alley, so I was kind of surprised by it. But yeah, he's been doing some pretty incredible stuff. Cool. Right. So what exactly are we going to be working on today? So today, I want to create a very specific animation. And that animation... Oh, by the way, I've actually decided I'm going to start posting... I'm going to start posting when I go live on Twitter. I never used to do that, but I'm going to start doing it just because I feel like I just never did it before, and I feel like maybe I should. So I'm going to start doing that from now on. I don't know if that's a good idea or a bad idea. Usually I don't like self-advertising in that way, but, you know, it is what it is. What was I looking up? I think I was looking up Chaos Game. Here. What? Wait, let me think. Yes, this is the visualization I was looking for right here. Cool. Okay, so yes, this is what I'm looking for. This is the visualization that we are going to be making today. Now, this is a bit more difficult to create than you might initially think. There's a lot of subtleties to it, and I want to talk to you about what the subtleties are. So it's over my head, but he seems to have released a new model to explain the universe. Right, that's exactly what I've heard, but I've heard nothing. Let me just Google what Stephen Wolfram is up to. IQ? That's the first thing. What is Stephen Wolfram's IQ? I mean, who cares? If you read Stephen Wolfram, or if you read any parts of his book, A New Kind of Science, you'll see, among other things, that he got a PhD in particle physics from Caltech at age 20. I don't know. Like, IQ, it's such a dumb metric, IQ. Stephen Wolfram, theory of everything. That's how you spell it. Oh, boy. Oh, by the way, I got this stupid comment this morning. So, let me go to YouTube. Let me just go to youtube.com/user/LeoSS. I've got this YouTube channel. A lot of people know about it. My most popular video is this one, Understanding 4D the Tesseract, right? So I got a comment today on that particular video. And that comment said the following. It said, "Duh, it's so obvious, you guys, but I understand if you don't understand. I don't blame you. I'm only 15 and I understood every word of what he said. Unfortunately, for small-minded people like you couldn't possibly grasp this no matter how hard you try. You have to have at least an IQ well above 450 like yours truly." And I assume he meant me. "I'm just the most intelligent being inside Earth. What's that, Einstein? Oh, how cute. Ha ha ha," snarks an oversized ego. "God, why am I just literally the best person ever, and I'm not struggling with addition at all. Nope, not in the slightest." I didn't understand this comment to save my life. I had no idea what he was trying to say. Right? Well, yours truly, and there was an and I assume he meant to put LeosOS here in the and. I get a lot of comments, right? A lot of comments that do some of what this comment says, like, let me just view image here, and let me see if I can make it just a bit bigger so you can see it a bit more. Right. So I get a lot of pseudo-intellectual comments that will say things like, "I have an IQ of 450, and fine, fair enough. I understand those comments. Those comments are trolls. I get other comments that are also in the pseudo-intellectual vein that are like, "I'm only 15 and I understand everything," and that's also fine. But this one was clearly poking at me, right? This one was saying, I think this guy was saying from my perspective, he thought I was a 15-year-old, which is fair. My voice is probably not as deep as it could be. So he probably thought I was a 15-year-old, and I was teaching everyone about four-dimensional vectors and stuff like that, as I was. And he was probably making fun of me because he thought that I was pretending to know I couldn't figure out what this comment was supposed to say. Like, I knew it was a troll comment, and usually with troll comments, I actually respond to troll comments, and I usually just try to dissuade them from speaking anymore. But man, this one got me. Impossible to tell if this is a troll or just a regular smart kid. Sounds like either a troll or someone who's arrogant about their own intelligence. Right, but they can't be that arrogant. Surely they can't. He's saying the person writing, is 15. Right. But what I think he's trying to say is that... So here's what he says. But I understand if you don't understand. I don't blame you. I'm only 15. I understood every word." And he said, "Unfortunately for small-minded people like you couldn't possibly grasp this no matter how hard you try." So he's obviously referring to the rest of the YouTube comments. But the way that he's doing this is he's trying to empathize with me, right? He's trying to be like, I too am a 15-year-old genius. So that's how I'm kind of reading this. And I'm not sure what's up. So my response to this guy was, "Are you okay, buddy?" That's all I said. And then I was like, "Feel free to join us on the live stream if you have any questions, I'm not struggling with addition at all. Nope, not in the slightest. Seems like it makes the entire comment sarcastic. Right, it is. It's definitely sarcastic. But it's just, I never had a comment that was such a train wreck as this one. And I've got some pretty good comments. One of my favorite comments is, someone once commented on one of my videos. He said, "If a calculator had a voice, it would sound like you." And honestly, I wanted to make merchandise specifically for that one comment. I wanted to make a LeosOS themed calculator. It runs on LeosOS and is a calculator. And every time you press a button, I will say 1, 2, 3, plus 4, 5, 6. Like, I will have like voice snippets. So when you press it, it actually has my voice saying really stupid things. I really wanted to do that so badly, and I've considered doing it. But I'll do it later. If I ever have merchandise, it will be on the top of my list of things to do. No, you guys have to remind me to do it. Like, I'm probably going to forget in a year's time whenever I make merchandise. Looking at it's more of their own ego message, more than something to act as a communication. Yeah, I agree with that statement. Anyway, I just wanted to say, I get really, really weird comments on YouTube sometimes. And that one right there got me. Usually I haven't, I've gotten so many comments about, let me just go to this video and let me just read the comments. Okay, I'm just going to scroll down a bit when the comments show up. You show me a 4D object in a 3D world on my 2D screen, and I try to understand it with my 1D brain. Very common comment. Everyone says this one. Brain.exe has stopped working. Again, very common comment. See that all the time. Cool, now explain like I'm 2. Fine. Loki wants to know your location. This comment section gave me brain damage. I played myself thinking I was smart enough to watch this video. Like, it's just, you get a lot of these, you know? I don't know. But it's just this whole comment section is just bad. And I know it's because I'm not moderating it as much. But the one that's like, this video should be age restricted, that one's pretty good. Like, some of these are really good. I don't know. They should give that guy an award for the longest run-on sentence. I'm sure there are more long run-on sentences. I hope it has an internal clock that says your whatever time happens to be your time bit whenever you change it. Oh. Yeah. Okay. Stephen Wolfram, finally we may have a path to fundamental theory of right, this is what I saw. I should have looked into it. I just didn't. I know I'm not on top of things. I'm just not interested. I know this sounds really dumb. I'm just not interested in this theory of everything thing. I'm just too interested in algorithms, you know? So, like, I can only be interested in, like, 5 things at a time. And I've got that booked out. I'm interested in, like, oh, actually, I can't think of anything I'm interested in right now. Besides the algorithms in the algorithm archive. I can give you a summary if you want. Yeah, please do. I'd be more than interested to hear it. Okay. Now, this stream is not about Wolfram's theory of everything, but it's an interesting thing to think about. Are you interested in making a list of things you're interested in? Oh boy. And then we sort that list with worst sort? Yeah, that's what I'll do. That is precisely how I'm actually, you know, okay. I have a theory that says that procrastination is your way of worst sorting through life. And let me explain. Okay, so for those of you guys who don't know what worst sort is, it is a sorting method, right? It's called worst sort. Worst sort, okay? Here's the idea. You've got a vector of, let's say, 2, 1, 3, and you're trying to organize the vector. Obviously, the correct list that you're trying to sort it to is going to be 1, 2, 3. If you're organizing such that the lowest is on the left and the highest is on the right, right? It should be very simple to sort. Your life is essentially trying to sort this vector, right? You're trying to sort yourself out, right? Okay. Now, the way worst sort works is by essentially saying that in order to find your perfectly permuted list, in order to figure out how to sort this method, instead of sorting it, what you're going to do is you're going to list out all permutations of the method. So 2, 1, 3 is one permutation. 1, 2, 3 is another permutation. 3, 2, 1 is another permutation. 3, 1, 2 is another permutation. You just list out all the permutations of this list, right? And then you have a list that you will then have to sort, right? Because, you know, you have to sort your list of permutations. And in order to sort your list of permutations, you create a permuted list of all your permutations, right? So now what you've done is you've created you first find all permutations of your 3-vector array, right? And then what you do is you find all the permutations of your 9-element array. And then you find all the permutations of your 81-element array, so on and so forth, until eventually you just resign and you say bubble sort, right? You just use some other sorting algorithm to solve it. So what I'm trying to say is, a lot of times what people try to do when they're trying to sort themselves out is they try to list every possible option for them to act on, right? They list out everything that they could possibly do, right? And then after listing out everything that they possibly do, they then try to act on something. And how do they try to act on something? Well, by trying to, again, permute that list of things that they could possibly do. And this act of constantly permuting lists and not actually acting on anything is, in my opinion, the act of procrastination. It's what holds at least me back. And I don't know. I thought about this the other day, and I was like, man, that's a perfect analogy, but I have nobody to talk about it to except for you guys here on stream, so that's it. I don't know. I don't know. That's all I'm saying. The basic claim is if general relativity and quantum mechanics come from the same underlying computational theory, this will explain how the universe works if we find the right parameters. And that's a pretty big if. Why is it all computational? Thinking more about Kaktovik, Inapak materials. Looks neat for numbers. I don't know. Anyway, that's my whole theory of everything. My whole theory of everything is that we're all trying to sort ourselves out, and we're really, really bad at it, so we're all just using worst sort and hoping for the best. That's my theory. A game theory. Thanks for watching. Okay. So, let's talk about what the visualization is that we're working on today. I really want to get something done today, so we're going to knock it out. As far as Wolfram's theory of everything is concerned, if he's managed to essentially find a way to treat the world as a simulation that you just have to appropriately parameterize, that's pretty cool, because parameterization is, I mean, it's a really, really, really difficult problem, but it's a known problem. It's something that people can attack. So what he's essentially done is he's transformed the way we think about the problem into a realm that people can actually attack. That's my opinion on that. I don't know. I mean, this is really cool, but again, there's big ifs and questions about. I don't know. I'm not. I need to look into it. I really should look into it. I'm not as interested as many other people are. You know, like when I think about who I wanted to be, like I never really wanted to be this guy who found a theory of everything. That's not what I wanted to do. The best thing that I wanted to do is just honestly what I'm doing here on stream. Just learn things for the rest of my life. That's all I want to do. And if I can just do that as a career, like that's a wonderful career for me. I don't care if I'm learning about like actually useful things or not. I don't want to like change the boundary of human knowledge too much. I just want to learn and do things, you know? Let's see. Thinking about, let's see. Looks neat for numbers. Inuit numerical system. Imagine thinking of numbers in bales of food and hides. Is that why my name is a number? Honestly, Wolfram is just using adinkra symbols like... right. I don't know anything about this. I'm sorry about that. Looking at Wolfram's theory as a software developer's approach to the explanation, his theory is crud. Good thought-provoking stuff, but interpolation shouldn't be that hard. Interpolation is a hard problem. I don't know. Like, I feel like... I don't know. Smart refrigerator. No, smart refrigerator. Thank you so much for following. Really appreciate it. I don't know why I had so much trouble with your name. It's clearly smart refrigerator. I'm bad at that. I'm just really bad at that. Okay. So let's talk about what we're doing today. Kayana Squatty is a film that mashes human evolution versus primitive ideals in videography. The coolest thing to me is that he's proposing that general relativity space-time curvature is actually a result of fluctuations in the fractional dimension of the universe. Okay, well that's interesting from a fractal perspective. I just don't know enough about it, right? I really should have, if we're going to have this discussion, I really should have listened more deeply and intently to what Wolfram said, right? Like Bohr and Rutherford diagrams. So I am super excited that people in this community are listening and understanding and doing their best to grapple with what Wolfram has recently proposed. But also it's not something I know about, so I can't really talk too much about it here on stream. Regardless, I hope you guys are all having a wonderful day, and let's start talking about what we're going to work on for today's visualization. So here's what we're going to do. We're going to have 3 points in space. A, over here, B, up here, and C, over here. Oh, I just need a C over here, right? And what we're going to do is we're going to create 3 functions. Function 1 is going to take some random point P and add A to it and divide by 2. So it's essentially going to output a value that is the midpoint between the input point and A. F2 is going to do the same thing, but for B. And F3 is going to do the same thing, but for C. And actually, that's, I don't know what I just did, but that was clearly wrong. Let me try this again. 2, 2. Also, so I use a pen to like, this is what I use in my mouse, right? I recently switched the nib to be one of these guys. So I don't know how to point this, but it's got like a spring in it. I don't know if you can see that on stream or not. You probably can't. I'm going to switch it out because it is making squeaking noises every single time I type with it, and it's driving me nuts. So let me just change that out to be, oh, I don't know. Should we use pencil-like or should we use... I'm just going to use the regular old nib. Let's go with that one. There we go. All right. I know that's not interesting to literally anyone. Ah, crap. I dropped it on the ground. But it was bothering me, so give me just a second. And... is this one just bent? Maybe. Okay. And we'll just go here. Cool. Right, 1 second. Chotto mate. Gomen. Ah. Okay. Should be back to normal. I'm not a physicist, so I'm probably capable of absorbing most of what he's saying. Wait, I'm not a physicist, so you're probably capable? Huh, interesting. Uptime, we've been up for about 30 minutes. Hey, Trash Talk, how are you? Today I found a neat geometric structure in my math art as well. Just leaving it here for your enjoyment. Oh, cool. Yeah, I'll take a look. Let's see. Looks pretty? Wait, pretty incapable? What? Oh, I assume you meant something else. Let's see. Oh yeah, nice. Cool. Okay. So let's go back to this. So we're going to have points A, B, and C, and we're going to have functions 1, 2, and 3. So what I'm going to do today is I'm going to create a visualization where essentially we show each of these points, A, B, and C, creating subtriangles. So for example, we're going to apply functions 1, 2, and 3 to A. That's going to create a point here, here, and here. Then if we apply it all to this triangle again, we're going to create a new point, again here, it's going to stay there, another one here, another one here, another one here, another one here, here. Oh boy, what's the next one? I think there's one. Let's see. So this one is going to go halfway to C. So we should have one here, and we should have one here as well, right? And so essentially what I'm going to do is I'm going to create all of the families of points. That's what I'm trying to do. So I'm going to have A, it's going to generate 3 children, and then all of A's 3 children are then going to generate 3 more children, and all of those children are going to generate 3 more children, and so on and so forth. And essentially you're going to have this exponentially growing tree that I want to model today. Steak, thank you so much for following, really appreciate it. So let's take a look at that and see what it looks like. So again, we're going to start at point A, and in principle B and C as well. And we will generate 3 children, which are going to move one halfway towards A, another halfway towards B, and another halfway towards C. That's going to generate 3 more children, 3 more children, and 3 more children. And of course, these guys are going to generate 3 more kids, right? So you're just going to have a lot of kids. A lot of kids, right? I don't know how many kids, but, you know, a lot. Well, actually, you do know how many kids. So because of the way I want to do the animation, I want to do it level-wise, which means I want to do it breadth first. And if you're familiar with breadth first, this essentially means we go through this way. So we're going to go through those numbers, and then we're going to go through those numbers, and then we're going to go through the next set of numbers, so on and so forth. Now, obviously, this is a puzzle that will just eat up your memory. So what we're going to do is we're actually going to treat each of these layers as a trit string. Okay? String. Hopefully you can't read that. There's no way you can read that. Let me try that again. And I'll make it yellow just for fun. That's not yellow. Rit. 1 second. String. Okay. So we're going to do our little trit string here. I don't know why. I screwed up with coloring, and then I had to make it consistent. You know. Anyway, it doesn't matter. So we're going to have our trit string. And the way I'm going to read this is, if you have the trit string 0, 1, 2, 0, what this means is you're going to take point A. You're going to take point A, and you're going to apply function 1, function 2, function 3, function 1, all to A. I think I missed a parentheses. Is that right? Yeah, I think that's right. So essentially you read this as 0 means you're applying function 1. 1 means you're applying function 2. 2 means you're applying function 3. And 0 again means you're applying function 1, right? 2.a. So this allows you to regenerate a consistently rather than just storing a large tree in memory. It allows for you to keep essentially just a trit string that you just count upwards in, right? So this essentially turns your previous computation of having to store some sort of giant tree in memory into essentially just keeping one linear index that you just, count upwards in. So it's a lot faster. I'm hoping this makes sense. Let's see. I missed a lot of chat. Got a 1 week school break. Cool. Nice. Already kind of bored. Sorry. In 3 weeks, I'll have an infinity school break. Unless I get my PhD, which I'm leaning against because my master's thesis made me realize how much I hate how academia works. The key is to troll it all the way through. No one will argue for absurdity against absurdity to defend your thesis. That's the best part of education. You can clone it all the way through it. I just jumped out. So everything else is a quotient of a by an even amount. I don't know what you're talking about. I'm sorry. A is just the initial point, right? So this would mean that, like, for example, I mean, if you plug this in, it would be like a plus b over, it'd be, sorry, a plus a over 2, then plus b over 2, plus c over 2, plus plus a again over 2. And then this is all over 2 again, right? So this would be what it looks like, right? So again, the point is just that you're applying function 1, function 2, function 3, and that's kind of the idea. Like an inverse Mandelbrot. I actually don't know what a Mandelbrot. I should know what the Mandelbrot is, but I'm not sure. I don't know. Like, I don't know the exact formulation for Mandelbrot. Again, I should, but I don't. Let me get some water. Okay. So let's go ahead and get this underway. So I'm going to move this over here, that over there. And just so I have some sort of visual flair up on screen, because, people tend to like that, I'm just going to have this in the upper left-hand corner of the stream, just right up here. Okay. Let me just stretch a bit and think about this really quick. Actually, I do want to comment on something about academia that Foldster brought up. Foldster specifically mentioned that he doesn't like how academia is run, right? This was something that I think I've mentioned a lot on my stream also, that I don't really like the way that academia is run either. But one interesting thing about Wolfram is that he's actually an independent researcher, right? Like, if you just Google independent researcher, independent researcher. I don't know why I have the independent scientist. And you scroll down here to the bottom, you should see Wolfram on this list. Here it is, right there. So whether you like Wolfram or not, and I know a lot of academics don't like him because he's a bit, I don't know how to put it, but some people consider him to be a bit arrogant. I don't know if that's true or not, just some people say that. He did break out of the academic mold, which is something rather exciting. It's interesting that he was able to do that, right? So, did you watch the stream yesterday? I did not. I know a lot of people did. I probably should have. I did not. Dragon School. Where's the Dragon School? I've also never heard of it. Is he a wizard? Not that I'm aware of, but he does do some wizard-y things, so maybe. But anyway, this is my point. If you're really interested in doing research, but you don't want to stick around in academia, I understand that, and I feel your pain. I mean, one of the main reasons I'm still doing this, I'm doing this stream, and I'm working on the algorithm archive, is because it is a route to doing independent research for me. And I think that'd be amazing if I could do that. Again, I don't want to like create a fundamentally new theory for the universe or something like that. But I do genuinely want to be able to do research in my own way and on my own time. And I think that's really cool. I'm still going to do research, but a lot of my time was justifying why my area of research is interesting to everyone. I only care if it's interesting to me. Right. But that's the thing. No matter what job you work at, no matter how you're doing research, you have to justify yourself, right? Whether that's to funding bodies or that is to the general public, you have to prove that the research you're doing is worth people's time, because that's where the money comes from, right? Let's see. This like psychedelic information theory, which I found more valid in my years of chemical drudgery. I want to do science, not marketing. There's an even more controversial figure in Eric Weinstein, Weinstein, who's doing independent stuff as well. Maybe. Let's take a look. Let me Google him. I don't actually know him. Maybe I should. Maybe I do. I just don't recognize his name. Here we are. Harvey. No, that's a different guy. You said Eric. I did spell the name right. Eric. Let's see what we got here. Eric is, let's see, the managing director of Thiel Capital, Peter Thiel's personal investment firm since 2015. He and his brother Brett Weinstein coined the intellectual dark web to refer to an informational group of pundits. Huh. Interesting. Dmitry Itskov is a private researcher from Russia with billions of dollars who's trying to reproduce the Japanese Aitken human consciousness network. Interesting. Cybernetic brains. Huh, cool. I mean, that kind of stuff is very interesting to me, right? But again, this isn't the type of research like. When I say I want to be an independent researcher, I don't want to do anything like that. You know, like, I'm not sitting here and like, oh, I don't want to be like the next Iron Man or Batman or something like that. That's not what I'm shooting for here. Like, I don't want to be like this guy who's developing things that like will change the landscape of human knowledge so radically that, you know, people are going to like remember my name for all, you know, humanity. That's not what I'm looking for here, right? What I'm looking for is just to be able to learn stuff I want to learn in a way I want to learn them. Like, that's all I'm looking for. You know, and it'd be cool. Like, it'd be amazing if I could do that independently, you know, because of all the issues we've talked about before with the academic system. But I'm not dismissing the academic system outright. It works well for what it does, and that's fair, you know. Are you sure you're not reading from a cyberpunk novel? Okay, so let's take a look at this visualization here. And let me get some water, and then we'll start trying to parse out this code here, and figure out what it does. You're the Archman? That would be the worst superhero ever. It's like, wait a minute. Like, every time you end up fighting someone, right? Like, you're fighting your big evil boss. You have to open up a terminal and, like, essentially build all the packages so that you can actually fight this fight, you know? Ever done ray marching shaders? I've done ray marching before, but not shaders. I've been wanting to do shaders for them recently, especially after we looked back at some of the impossible lens stuff that we did a while ago. I think I still have some visualizations, but there were some really cool visualizations we made of a time-dependent ray tracing scheme that I don't think had been published before, and I wanted to turn that into something, but I can't turn it into anything until I, you know, go through the computer graphics research and stuff like that. So I need to actually like create like a Blender plugin or something to do it, and I just haven't gotten there yet. You know, it's one of those things that I would definitely look into if I had the time to look into it. You know. So like, there's a list of things I would definitely do, and I'd be really, really into. I'd be really, really into it. Like, if I was working on this project full time, but I'm not. I'll eventually get into shaders. Yeah, I tried to get into them, then I kind of dropped off. I probably should. You should mess with ray marching in the distant future, right? If you'd like it, if you're into fractals, math, or tech art. Yeah, I'm relatively into it. Honestly, I'm not as into tech art as some other people are. Like, don't get me wrong, like, creating fractals is incredibly cool, but for me, like, I find the less visual algorithms also just as compelling, you know? Like, for example, the Schoenhage-Strassen algorithm, which is how you multiply two medium-sized integers, is literally just a convolution. But it's super cool, and I love the idea. And so when I think about it, I don't need the visually appealing nature. Like, I don't need... I need to turn on my fan. Give me just a second. It's getting hot in here. ATR, Human Information Processing Research Laboratories, actually was run by Tsutomu Ohashi, who produced the soundtrack for the anime movie Akira, and employed renowned AI researcher Hugo de Garis with billions. Supposedly, it was either a failure or something that made it to the Montauk. I don't know what these are. Life is so much stranger than books and films. I would tend to agree with that statement. Like, the way I see it is, people get lost. People get lost in fantasy realities. You know, they get lost in, Wheel of Time, Lord of the Rings. What are some popular? Game of Thrones. Just a whole bunch of, like, I don't know, Star Trek, Star Wars, all these kinds of things, and then they can't find themselves interested in, like, real world things. And it's just like, well, there's so many cool things around you. Why don't you just find something you're interested in, devote yourself to that? Like, read about, like, in my case, I read about algorithms all the time, and I tend to find myself more interested in algorithms than I ever was about any fantasy novel. Although, look, I definitely read my fair share of fantasy novels, but there was something about just going to the list of algorithms on Wikipedia and just, like, working your way through it that is just so fulfilling. I don't know. Let's see. Real life has worse pacing. Yeah, I mean, that depends on you. I mean, if you're just really slow at doing things, I mean, that's your fault for setting the pacing so slow. But no, I understand exactly with what you mean. Okay. Also, I didn't mean to sound really arrogant or rude there. That wasn't what I was going for. I was just saying that you do in some ways set your own pace, you know? And so if you find that something isn't particularly interesting, you have to find a way to make it interesting sometimes. Ever do leak code problems? I have not. Is there any algorithm cookbook that you would recommend? Not beside the algorithm archive. That's kind of why the algorithm archive exists. I used to do the same. I read all kinds of complicated algorithms just for the sake of curiosity. Right? It's super cool. It's really, really fun, in my opinion. Okay. So what do we have here? We have this increment trait thing, which was written by Cropep, and I need to learn how it works. Now, the truth is, at the end of yesterday's stream, I said I would figure out how it works, and then I'd come back tomorrow, and I would know everything. But that didn't happen because I'm busy. You know, I'm working on climate simulations and stuff like that. I've got too much on my plate to devote much more time outside of, stream time to do this during the work week. So I will kind of start working with it now. Wait, what? Oh, what? That's insane. Oh, no. Okay, I want that. That is what I'm looking for. Let's see, what do we have here? Ever do leak code? I have not done leak code problems. I used to do the same. Let's see. You define the inverse compounding function. I'm gonna be honest, Jump Out. I very rarely understand any word that you're saying. Sorry about that. So you define the inverse compounding function. Are you talking to me? Because I don't think I did that. I'm like 90% sure I didn't do that. So I'm really sorry. I'm doing my best. Well, then no, I didn't do that because that didn't happen. The inverse compounding function was not written because that you bracketed A, B, and C. Over here? Wait, 1 second. Yeah. You bracketed A, B, and C by 2. I never drew a yellow squiggle. I did draw a yellow parentheses, which is what these were. But also, it's not an inverse compounding function at all, right? That's not how this works. It's literally just a switch. All you have to do is case 0, case 1, case 2, and then you just apply the appropriate function to it. That's all you need. So you just apply function, and you just have a while loop iterating through the trit string. There isn't anything needed. There's nothing crazy to do there. It's all, in my opinion, straightforward. There could be a more efficient way to do it, but right now, today, what I'm focusing on is just getting the right trit values out. Just counting up in the appropriate way. That's what I need to do today. Now, the truth is, I've been struggling to do this for months. and I'm going to try to do it, as quickly as possible. We'll see how far we get here. But yeah, we'll see how this goes. Okay, so right now we have this increment trit thing here, and then we have this print trite here. So what I have is I'm running the Sierpinski-Hutchinson operator here, and I'm just running through all of these values. So let's go up here to Sierpinski again, Sierpinski chaos, Sierpinski Hutchinson. What I'm going to try to do is I'm going to try to figure out how to just print the bit values out, and then we'll go from there. So we're going to have some sort of trite value, which is going to be 0, 0. FV is equal to PV times 1 plus I raised to the minus 2. I don't see how that's related at all to anything that I was doing here. So I'm sorry about that. Okay, so let's keep going. Yeah, I don't see how that's related at all. I'm sorry. Okay, so let's keep going. That's what you drew in parentheses. That is not what I drew in parentheses. Besides, it doesn't matter what I drew in parentheses because, in principle, f1, f2, and f3 could be arbitrary functions, right? What is FV and PV in this notation? I'm sorry, I'm not following. I'm really sorry about that. Okay, so let's go. So for int I is equal to 0, I less than 3 times 3, future value is equal to present value times 1 plus I. I don't know where the I is coming from. Raised to the minus 2. Yeah, that's what you just said is this. You just said that journal new page before. You said F is equal to I's interest. Okay, so now I'm completely lost. Yep, I have no idea. You said your out. Oh, well, let's try that again. Journal new page before. You said out is going to be equal to in over. What? Yeah, no, I'm not. I don't think that's related. Okay, so let's keep going because that is at least for what I'm doing right now. That's unrelated. Right. Okay. So what we're gonna do is we're gonna say for int I is equal to 0. What I want to do is I want to output. Let's see, value.first and value.second. So what I'm trying to do is I'm gonna try to figure out how to get the actual bits out of here. So we said trite value is gonna be 0, 0. Okay, and then what we do is we say for I is equal to 0, I less than 3 times 3 times 3 times 3, we do I plus plus. So I'm going to not print this out right now. Oh, sorry about that. Never mind. Yes, this is what I'm looking for. So I'm not going to output this right now, and then we're going to try to figure out what's happening. So if I do G++ and get the last... Oh, G++. And then we run /Sierpinski. We get a list of trites, right? So let's go through this list of trites. It starts as 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2. So this would seem like it's the appropriate list of trites. However, in order to get the system that we're looking for here, we need a slightly different counting system. So normally if you print up trites, journal new page before, you'd have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2, so on and so forth, right? So 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 2. That would be how you normally count up trites. However, what we're interested in doing is 0, 1, 2, then 0, 0, 0, 1, 0, 2, sorry, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So we're interested in having 0 different than 0, 0, right? So that's the important bit here. And we have to allow for that possibility. So yeah, it's base 3. It's a trit, not a bit. So it's a trinary system instead of a binary system. So that's why it says print trite, right? Like, although I don't know if trite is the same as trit. I'd never seen it spelled that way. I always saw it spelled TRIT. But regardless, this is what we have. Okay. So what is print trite doing? So print trite is going to take some sort of number and then int trits. Okay. Um, so the int trits right here, we're going to put down 4. And I just need to figure out, oh, 4 must be how many, let's see what happens if we just change this a bit. So let's see what happens if we change this to 2. So we're going to run g++ dash Sierpinski and run that, and we get, let me just scroll up to the top here. So we get 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 0. So let's modify this. We're going to do print trite, and it's going to be value, and we're going to say, I don't know, we're going to say level is what I'm going to call it. Okay, we're going to say level equals 1, int, there. And we're just going to increment the level every time we are I guess multiple of 3 isn't quite right. So, let's say if I is equal to 3 raised to level, then we're going to do level plus equals 1. Okay, and let me add a parentheses here. I don't know, maybe I need to use POW for C++, I don't remember. Nope, that seems to work okay. So we're going to run /Sierpinski, that clearly didn't work. Yeah, okay, let's try that again. Oh, you were right, my bad. Thanks, Kibisis. DD. So let's do just XP. Okay, let's try that again. G++ /Sierpinski. Okay, that, right, that, okay. Not quite what I was looking for. Let's see what we have here. Reminds me of that topological soliton function I mapped. Yep. The worst thing is that equals plus compiles fine. Right, it probably shouldn't. But hey, it's C++. You know how it goes. So if I is equal to 3... Oh, it should be 3 raised to level. Not... that's my bad. Okay, so we'll do G++ /Sierpinski. If I is equal to 3 raised to level. So that would mean if I is equal to 3, we're then going to add 1 to a level. If I is equal to 9, we're going to add 1 to a level. What? So print trite is only going to print 2, is only going to print, so if level is equal to 1, it only prints 1 value. If level is equal to 2, it prints 2 values. If level is equal to 3, it prints 3 values, something like that, right? So what I'm saying is that we want to count 0, 1, 2. So we need exactly 1 element to count 0, 1, 2. And then when we go to the next level, we're going to need 0, 0, 0, 1, 0, 2, right? So what I'm trying to do here is I'm trying to say we're going to count 3 one-digit numbers, 9 two-digit numbers, what's 9? 27 three-digit numbers, and 81, oh wait, no, 27 times 3 is going to be, what's 27 times 3? Is 81 correct? 81's correct. Right? Yeah, 81's correct. So then 81 four-digit numbers. That's what I'm trying to do here. So what I actually got was definitely not that. So let's see. Value is going to be equal to the increment of value, so we're going to increment it. I mean, I guess I could just do something really dumb, like dd, and then paste up here, and do 1, 2, 3, 4. I mean, this is a dumb way to increment it, but at least it's working. Oh, no, dd, and paste down here, sorry. Should be this is what I'm looking for. Okay. Level is equal to 1. So now the problem is it's not working exactly how I want it to go. So let's do G++. Oh, well that gave me a lot of issues. Oh, maybe because that's not how you assign a value. Oh boy. Hmm. How am I going to assign a value? So what is a trait? What is a type of a type def unsigned long long ll, and then we do std pair. So I guess what I'm looking for is, I think if I just change these to squarely brackets, it should work. So we do this and that. Yes, that works. So Sierpinski. Yeah, that's clearly wrong. Whatever I'm doing is clearly wrong. Is a trait 8 trits? It should be no. Okay, you're right. Let me look up notation wise. Again, I didn't write this section of the code, and usually I like writing all the code myself. But let's see. So what is a trait? Ternary numerical system. A trait. Some ternary computers, such as Ceton, define trait to be 6 trits. Wait, what? We definitely don't have 6 trits, so I don't think trait is correct. I see. So a trait is okay. Let me think here. This take okay. What exactly? I don't even know what a long long is in C++. I've got a lot to learn. Long long. I should know what it is, but what's the difference between long and long long? I'm transitioning from Java to C++. Long and long int are identical. So long long and long int. In both cases, the int is optional. Long and long int are at least 32 bits. Is 32-bit the minimum? Oh boy, this is all stuff that I should know, but I don't. Okay, so let's see. What do we have here? Long long. Let me just Google this. I really need to set Google back to my my default search engine. DuckDuckGo is great, but I never honestly find what I want to find. Right. Are we sure we're multiplying the z-scale before raising... Wait. Are we sure we're multiplying the z-scale before we're raising the tetras? I don't know what you mean. I'm sorry about that. Okay. So, what do we have? Right. So, if I is equal to 3 raised to, we're going to print trait value and then level. Okay. So, I'm techno-babbling. Is it working? Maybe a bit. The problem is in this stream, I never really know what's techno-babble and what's not. You know? Sometimes people will say things and I'm like, that seems valid. And I know I don't know that much, right? Like, I know, yeah, I've got my PhD and everything. And you'd expect for me to be able to, like, follow suit. Like, if someone just, I don't know. There's a lot of times that a lot of times there's the question of, is this person just making stuff up? Or is this legitimately, you know, like, is this legitimately correct? Okay, I don't know how to put this. Sometimes people will say things, and I'm like, I don't know. Like, so the thing is, any other stream would have called me out. Wait, what do you mean, any other stream? I'm actually kind of confused about that. Would other people just say, so if you said, are we sure we're multiplying the z-scale before we're raising the tetras? What I assumed you meant was, in this for loop, the z-scale here would be this 3 by 3 by 3, and then the tetra value would be raising the level by 1. That's what I assumed you would have meant, but I wanted to make sure that was what you were saying. Like, that was the best I could understand. If you're saying you just made up a bunch of gobbledygook, that's fine. I don't mind that. It's just that, you know, I need to learn when people are gobbledygooking me, you know? Okay. Here's a flattened z-scale that I was able to map on Google Charts. You need to have a 15-year-old 450 IQ to understand chat. That's sometimes how I feel, honestly. I mean, the truth is, right, there have been several youngsters in this community, I will call them. And by that, I mean people who are not half my age, but I'm 27, right? So half my age is basically 15, right? It's 14, but basically 15, right? And so there are people who are like 16, you know, in chat, who are fundamentally able to just bring new opinions to the table that I would have never considered before, right? And when they say things, when they bring such things to light, I am genuinely inspired by the creativity and the intelligence of these young people in stream. Does that make sense? Like, there's a lot of people on this stream that are just fundamentally inspiring, not necessarily because of what they say, but because of the age at which they say it, right? Like, does that make sense? And so for me, I that's one of the things I love about this community. There's so many people here who are smarter than I am. And I know, right, I've got a PhD. You know, I'm working at MIT. You would expect for me to know what I'm talking about, but the fact is sometimes I don't. And I love that people can call me out on it and they can tell me, hey, look, you're an idiot. And I'm like, yeah, okay, I'm an idiot. You know, I feel like you're overestimating chat, but I'll take the compliment. Yeah, maybe. But you have to admit, there's some really intelligent people that have come into this community, and it's just phenomenal, you know? It's one of those reasons why when I think about being an independent researcher, I genuinely think it could work, because there's so many smart people out there, and if we could just get a small fraction of them, you know, an incredibly small fraction of them, just to hang out with us, oh, we could get a lot of stuff done. Okay. So what are we going to do here? We're going to say, I'm going to try to figure out why this isn't working. If I is equal to this, let's not print the trite anymore. And I'm gonna quit this and quit that, and I'm just gonna print out just a stupid statement: std cout, and it's just gonna be something stupid. Yo, dog. All right. Yep, that's perfect. This is exactly what I want. This is how you write error messages. I mean, I know some of you guys aren't as well versed in high performance computing, but if you were, you'd know that this is very standard. That's way too many yo dogs. I was expecting 4 yo dogs, not 100, or how many were output. Do you know how to use a Wolfram language? I do not. Sorry about that. Okay. So, what are we going to do? That's way too many yo dogs. I wanted 4. So my question is, why are we outputting so many of these yo dogs? You know, I was expecting, again, we want 4, not 400. So we're saying int I is equal to 0. I is less than 3 times 3 times 3 times 3, right? And then we do I plus plus, right? And we say if I is equal to 3 raised to some level, we're going to output yo dog. So let's output I in all of these cases instead of yo dog, because, okay, we'll keep the yo dog because I like the yo dog, but we'll also output I, and then we'll do new line. Let's just do yo dog there. Okay. And now we're going to do g++ dot slash Sierpinski. And let's go up here. So 1, 2, 4, 5, 6, 7, 8. That doesn't make any sense to me. If I is equal to 3 raised... Oh, that's because probably I need to use pow. Let's just change this to pow of 3 and then level. G++ dot slash Sierpinski. Let's see what we output. We output, I think, still, no? Oh, we only output 3 that time. Okay, so if the level is 2, oh boy. The Wolfram language melts my brain, but I know it's smarter than me, so I don't hate it. You guys are talking about Mathematica? Let's see. Maybe I'm thinking of a different Wolfram language. The inverse covariant looks closer to Sierpinski as a spline. I don't know. Check. Oh, yeah, let's take a look. Oh, is this a Wolfram physics thing? Yeah, it's a Wolfram physics. We were just talking about this a second ago. Visual summary. Yeah, it's stuff I should know, but I don't because I'm an idiot. But super cool. I'm glad that people here are interested in it, right? Okay, so we're printing out 3, but then it should be 3 raised to a level. So it should be 3, and then we should also have been output 9, and we should have output 3, and then we also should have output... Oh, that's because the level isn't increasing. Yep. Yep. Okay, let's go. So we're going to go here. We're going to run g++ dot slash Sierpinski. We have, should be, okay, we have 3 yo dogs, but that's fine. I think that's actually fine. So let's go here and let's print our trite now, and hopefully we get the right trite. So let's dd here, write this. Go over here. We're gonna run g++ dot distribution. Okay, 0, 1, 2. 0, 1, 0, 2 is... Nope. Not quite. Not quite at all. I think it's because I'm not appropriately zeroing it. Yeah. So we had just had a discussion about it a few minutes maybe before you came in, Circumoto. But yeah, it is amazingly cool. And I'm really, really happy that, you know, people like Wolfram are looking into it. On the other hand, because we had already discussed it for like 20 minutes, I feel like I didn't want to talk about it too much more on the stream because I do want to get something done today. So that's kind of where I'm at with that. Again, it is incredibly cool stuff, and I really want to learn more about it. And I'm super happy. You know, Folster gave me a small update for what it means and all that kind of stuff. And yeah, I'm really happy that people in the community also find it really cool. It's great. It's great. But I just didn't want to talk too much more about it here on stream because I've already discussed it. Not really at length, but as much as I can discuss it because I don't know so much about it. Okay, so, we had a huge discussion about like why it's cool to be an independent researcher, and I would honestly argue stuff like that is stuff that he can only do because he's an independent researcher. Does that make sense? Like if he was tied to a university, I feel like he'd be bogged down with a lot of unnecessary stuff that he just wouldn't do as an independent, right? You know what I'm trying to say? I don't know if that made any sense, but I'm hoping someone in chat understood it and they pretend it makes sense, right? So, right. So let's see here. We have the trite pretty much printed out, as we would expect. Oh no, it's not quite. I think it's because we want to print trite. I think we want to print trite here. So let's run g++ dash Sierpinski, and let's scroll up a bit and see what we have. So 0, 1, 2, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Oh. Interesting. We don't want it to be. Okay, let me think about this. Maybe we want... Ooh, how do we do this? We're looking for... If I is equal to pow... Oh, what are we... I'm actually confused here. Let me think about this a bit. I'll pretend I understand. Cool, thanks for that, Fishy Poos. Really appreciate it. And again, actually, if you guys have any questions, comments, concerns, anything like that, feel free to let me know, and I will totally address it as soon as I see it in chat. I do my best to describe everything we're doing in as clean a way as possible, but sometimes I fail, you know? And, you know, I've been incredibly tired recently, ever since I moved to the US, and my stream has happened in the evening. I've just been a little bit more out of it during the stream because, quite frankly, I've already worked a full day, you know, and then when I come to stream, I'm just tired, you know? And that's just how it goes. Okay. So what we're going to do now is we are going to modify this. So it only increases the level when we... Oh, how do I do this? I guess what I'm going to say is diff... Oop. Int diff is going to be equal to... we'll just say 3. Okay? Now let me think. How are we going to do this? I'm going to say if I is equal to diff, okay, and we're going to go down here and we're going to say diff is going to be equal to, we're going to plus equals pow of 3 raised to the level. Okay, so basically this means that I think this should be what I want. Let's go ahead and add a semicolon there, write this, and go into G++. Then we're going to run /Sierpinski, and let's see if this actually did what we wanted it to do. So we have 0, 1, 2, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Then we have 0, 0, 0 all the way to 2, 2, 2, and 0, 0, 0, 0 all the way up to... 1112, but it seems to be counting up correctly until that point. Let me think. Why? Okay, we'll think about it a bit. I will pretend I understand. But regardless, we do have an appropriately printing trait now. So we have a set of values that is iterating, counting up the way that we expect now, which is good. Now, this isn't the most efficient way to do it. Probably what I should do, if I was a bit smarter, is I would change it so the print trait value up here. Okay, so what I'm going to do is I'm going to commit what I have. Okay, let's go ahead and do git add Sierpinski .cpp. And I'm going to say git commit -m, adding, what am I going to say here? Version of code that counts trits in a, hello there. So let me do ternary counting system. Okay, so there's a numeral system that we're looking for, and that numeral system is, I think, bijective ternary. Bijective ternary. I want to say that's what it is. Let me just Google bijective ternary system, because I think that's what I'm looking for. Bijective numeration, ternary. Yes. So here's ternary 0, 1, 2. Oh. What? Bijective base 3 is going to be 1, 2, 3, 1, 1, 1, 2, 1, 3, 2, 1. So we're looking for bijective base 3, but not bijective ternary. Interesting. That's super interesting. So it's 0, 1, 2, 1, 0. Interesting. So we're looking for bijective base 3. Bijective base 3 fashion. Okay. So that's interesting. I just learned right now that apparently we're not counting up in trits. In fact, we're just counting up in binary base 3. Bijective base 3. That's what we're counting up in. Aiden Mig 9, thank you so much for following. Really appreciate it. Let me get some water. And let's talk about what we want to do. I'm not particularly happy with how we're counting these numbers. And I realize I've just spent like 45 minutes doing nothing but trying to count upwards in base 3, which is deceptively challenging, I'm going to say. But it sounds pretty straightforward, right? I feel like every time I do a string, every time I do a stream, it's always on something that seems straightforward, and then I just fail miserably at it. I mean, that's like the crux of every Simuleo stream, you know? Okay. You know, man, I still want to make that calculator. I really do. Okay, let's keep going. So let's open this up. Sierpinski.cpp. No, just more systematic. Maybe. Let me think here really quick. So let me explain the problem in a way that I hope makes sense to everyone, right? So this right here is a ternary system. Ternary. This is bijective base 3. Bijective, base 3, right? So this guy over here, this is bijective base 3, and this is ternary. Okay? We want bijective base 3. What we have is a system that counts up in ternary. A system that counts up in ternary and then is modified to be bijective base 3 when we need it. Maybe that's what we just use. Maybe for now that's what we do. And then I just put a to-do statement and I say, let's go ahead and modify this later so that it is actually bijective base 3. See you, Trash Talk. Thank you so much for coming in and have a wonderful evening. Yeah, see you around, man. So let's go ahead and do to-do. Wrong commenting style. Modify traits to work with bijective base 3. And let's just keep going because I've been waiting on this visualization for a while. And quite frankly, we are kind of, I mean, we're getting to where we need to go. So we're returning a number here. So let's see, we have increment, we have print trite, and trite is going to do std cout. Oh boy. Okay, so we're going to have to modify print trite so that it outputs a string is what I'm going to look for here. So we're going to do std string. Okay, and instead of couting things, we're just going to push back a string. That's what we're going to do because that's what we're going to do. It's not the most efficient way to do it, but hey, I don't care about efficiency. I just care about getting this done at this point. So let's go ahead and get it done. So we're going to do trite number. We're just going to do std string. What? Oh, good. I thought I was off by spacing. And we're going to do std string. What are we going to call it? We're going to call it value. No, we can't do value. We're using value elsewhere. So we're going to do value underscore string. See, this is how you know. This is how you know this guy knows programming. Based on his naming conventions that are all awful. Think I'm lazy? Thank you so much for following. Really appreciate it. Okay, so what we're going to do, you can just push back a string in C++, right? I don't remember. String push back C++. I think it's just string.pushback. This is one cool spline. Yeah, let's take a look. Okay. Oh yeah, super cool. Nice. Okay. So let's see. It is just pushback. So we have the string, and so we should be able to say value string underscore string dot push back, and let's just push back a 1. Okay. And we're going to yank this here, paste there, and paste there. And we'll push back a 2. And we'll push back a 0. And let's delete this guy, and that guy, and that guy. And then we don't need to push back a new line anymore because we're returning a string. So now let's see. I guess it is kind of weird that we modified print trite. Print trite should definitely print something, right? I'm going to remove the print trite functionality entirely. I'm going to change this to save trite. And then we're going to look for print trite down here. And we're going to say value underscore string is going to equal to, what did I call it? I called it save trite. Value level, and then we're going to do std cout. Right, and let me also just define the std string up here. Okay, and we're just going to print out the value string down here. So std cout value string and new line. Okay, so this should give us the same set of numbers as we had before. Or not. Yeah, maybe not. It could just be that. Yeah, okay, fair enough. Can we just, how do we concatenate strings in C++? Surely, can we just do plus equals? Maybe we can. Maybe I was being really stupid with this. Let's just do plus equal. Value string plus equal 2. Value string plus equal 1. And again, we'll do it here. And again down here. Okay. And let's see what this looks like. Write that, and let's see if that compiles. It does. I don't know, did it? Let's try it again. Function no return statement. Oh. Return value string. That should compile. Now we're going to /Sierpinski. Did we get the right numbers? I think so. It looks like it's printing out correctly. 0, 1, 2, 0, 0. Right. Okay. So now we just need a function that will just iterate through our string, value by value by value, and apply the appropriate functions as necessary. So, right, let's go. Right, the first thing we need to figure out is, so let's say we have the string that is journal new page before. So let's say we have the string 001. What does this mean? This means we're going to be applying function 1, function 2. That's what we're going to be applying. So my question is, actually, which order do we read from? And I think we're going to be reading from the left to right. I think that's what we need to read from. And so this is going to be F1, F1, F2 on A, B, or C, whatever it is. Something like this. Okay. That seems to work out okay. Let me check on my... Oh, okay. I just screwed something up big time on my side stream. Let me just... Give me a second. Sorry about that. Here we go. Okay. And we will go to that. Okay, I think this is good to go. Cool. Okay, so let's keep going here. So we're going to have 001 means we're applying function 1, function 2 to A. So now we just have to create our function in order to apply our functions to this set. So I think the first thing we need to do is we need to create our set of functions, which I think I already created. How would I not have created it already? Sierpinski chaos. Oh, okay. I guess I haven't done it yet. So let's go ahead and create our functions. And we'll just call them, I think, function 1, function 2, function 3. I'm not going to be crazy with this. And they should all return points, and points are going to be vex. So let's go. So up here, we're going to create our functions. I'm going to put them up here. So we're going to say vec function 1. I mean, I guess I should call it function A. It doesn't matter. It's just, I've been notating them as function 1, function 2, function 3. LoneZQT, thank you so much for following. Really appreciate it. So function 1 is going to take what? It's going to take an initial point. So it's going to take a vec point. And it's going to take vec A. And all we're going to do is we're going to return point plus A over 2. Wow. Look at this amazing function here. We're going to make another one. And another one. Wow. I'm sorry. I'm just being a stupid person. Function 3. And we'll... You know, actually... This could all be done with a single function. We don't need function 1, function 2, function 3. Let's just... Ooh, hello. Let's just say this is going to be Sierpinski function. We don't need function 1, function 2, function 3. And then we're going to say point 1. And we're going to call this point 2. And in fact, we should probably just call this midpoint. Okay, and this is just going to be point 1. Oh, hello. And point 2. Oh my gosh. Over 2. That's all we're doing. Trying a perpendicular function or equilateral distance. Okay. So we're going to do midpoint. And let's just pop down here and let's modify all of these functions in our Sierpinski triangle function, Sierpinski chaos function, so that they use the midpoint. And let me see what we need to do to make that happen. So we're going to have triangle points 0 plus point x, and then triangle points y plus point... Ooh, yeah, that's what we should do. 1 second. Let's multiply this by 0.5. All right, let's go. That does nothing. It does literally nothing, except for the fact that multiplication is slightly faster than division in many cases. But, like, it doesn't matter. It does nothing, but, you know, it does something. It's sometimes when you write code, it's not so much about the code that you write, but the spirit of the code that you're writing. And I can tell you, this code has spirit. I don't know why I just said that. I'm sorry. Please ignore everything I say from now on. So we're going to say PT is going to be equal to midpoint of, and it should be triangle point 0. Let's do 0 dot, and point. Is that it? Let me compile that. Does that actually compile? Yeah, let's go. Okay, D, yank, paste, paste, D to D, there, and we're gonna do triangle points, 1 and 2. 1 second. 2 here. Let me compile it one more time, and I'm actually gonna move down, and I'm gonna redraw our Sierpinski Chaos video, just to make sure it turns out the way we expect. And that's one way just to stupidly test our midpoint thing to make sure it's working the way we expect. So let's run /Sierpinski. Right, this video should still be running, but then we should get a new video on temp video.mp4. And let's just make sure that video is what we expect it to be. Oh boy. So far, it's been a pretty productive stream. I'm pretty happy with it. Sure, yeah, we're kind of cutting corners a bit, but that's the nature of programming. Sometimes you cut corners, and that's fine. Okay, draw 3, erase 2. I have no idea what you're saying again. I'm so sorry. Maybe I should know what a trinary perpendicular system is. Okay, it is still rendering the video. Give it just a second. I feel like this might take a bit, but I don't know why I feel that way. You know, so we'll just let it do its thing. You know, it'll take maybe a second or two, and then we'll get our animation again, and we can work with it from there. So actually, no matter what, at least by tomorrow, we will be doing the next animation, which I'm really happy about. I've been kind of putting this animation off for a while because it's difficult to do. Like, I'm excited about it. Like, it's really cool. But it's just difficult to do this animation that I've been trying to do. But now I think I know how to do it, and I'm super excited by it, you know? I don't know. Maybe I'm too excited by it. But we'll just let this render. How are you guys doing? I hope you're all having a wonderful day. Night, afternoon, morning, evening, whatever time it happens to be your time. Yeah, cool. It's rendered. Good thing I didn't have to do any more small talk, right? So we'll do MPV temp. Video.mp4, and there it is. Beautiful. Okay, so I'm going to go ahead and copy. Where is it? Oh, come on. There we go. I'm going to go ahead to copy temp. Oh, it doesn't matter. It's the same video. I'm just going to keep this playing up in the upper left-hand corner. There we go. Let's go back to the Sierpinski chaos function in here. So now that we have our midpoints, our midpoint functions, we should be able to, I guess we'll call it apply. Oh, what are we doing here? I guess what we'll do is we will call it, so I think what we'll do is we'll return a vector and we will apply, I'll call it apply trite. Meh. And what we're going to do is we're going to read an SED string, and it's going to be called trite value. What did I call it before? Value string. That's what I'm going to keep that notation. It's dumb notation, but that's what I'm keeping. So we're going to do apply trite, and it's going to take this and I guess an initial point to act on. So it's going to be vec point. Okay. Let's go in here. So now all I have to do is read through the string element by element and apply that function to the element. So we'll say while, oh gosh, for I equals int I equals 0, I less than string value string dot size. I believe that works. And then we'll do plus plus I. Okay. So we have value string dot size plus plus I, and I should, unless I'm a complete moron, which again I might be, I'm going to put a switch in here. So we're just going to put the switch in here, and we're going to say switch on some sort of value. Okay. And what we'll say is we will say, I guess we need the point here, but we also need a set of std vector of vec triangle points. Something like this is what we're looking for. I don't know. I'm just making it up as I go along. So we'll see. Pop this down here. 5/11 is the most equilateral of Sierpinski formats. Cool. Okay, so we're going to switch value, and we're going to say... How do you just switch again? I always forget C++ syntax. But I know I have a switch in here somewhere. Case 0. Right. So in here we're going to do case 0. And then we have to break. And what are we going to do? So we're going to say midpoint of whatever point we have in. And then we're going to do triangle points of 0. And then we're just going to say that... Oh. What are we going to say? We're going to say that point is going to be equal to midpoint of point and triangle points of 0. Make sure triangle is spelled right. Okay, so now we're going to have another one. So let's add a semicolon here. We're going to do yank 3 yank, and we're going to do paste, paste. We're going to have case 1 and case 2. And we're just going to modify this to be 1, and we're going to have another one that's 2. Probably better ways to do this, but you know, it is what it is. The Illuminati. Hello. Okay. So we have these midpoints done in there. The switch should be done. So now all we have to do is figure out the value. And I think, unless I'm completely wrong here, we can just do value string. We'll say value is going to be equal to a value underscore string of I. And we want to turn that into an int. Oh, how do we turn strings into ints? C++. Let's see if this compiles. I'm going to do my first guess, and when this doesn't work, atoi string.c string or stoi. Let's try that. It's std stoi, which is string to int, I assume. Okay, let's run G++ and watch it fail at compilation. Cool. Okay. So it might be that we're unable to iterate through strings in that way. So let's go ahead and say accessing strings. Oh, hello. What? What? Oh. Accessing strings C++. Elements C++. Accessing character elements from a string. Let's see. S. Okay. S is a character. Okay, so maybe that's the issue. So the issue here is no matching function call for stoi. So it's a character. So I think we want choi. No, choi is not a thing. So let's see what we have here. So before on DuckDuckGo, it told me to do atoi. Also didn't work. Okay, so let's keep looking at this. Let's see if we can figure it out. So the type of value string of I should be a character. So how do I convert a string to an int to a string? Let's see. I think we are able to. Why don't I just do it this way? Why am I worrying about trying to get into an int when I can just do this? Value is going to be equal to the value string of I. And I just have this as a string. That also didn't work. Switch value. Switch quantity not an integer. Never mind. That's because switches work that way. Learn something new every day. So we'll say std value string. So we'll say okay, so this needs to be an int then. Okay. So we have value string. So how do I convert? How do I convert? So we have printf. I remember this always being a pain every single time I used to do it. String 123, n is stoi string. So if I do std, this didn't work before if I remember correctly. But I have very bad memory, and I know I just did this 2 seconds ago. But that's going to fail. Right. Because no matching function for... But then also when I tried atoi, that also failed. So rat, g++, that also failed. And it says invalid conversion from GNU, C++, Alex traits, SE allocator, char value type, aka char, to constant char star. Do I need to do this dot C string? Make value char and switch to char. Oh, I didn't know. So switch can work on char, but not string. Okay, that's good to know. Let's see. Yeah, I thought switch could work on something other than int, but for some reason I didn't like that. Yeah, so that error request for C string. Oh, well, that's my bad. Oh, no, it's not my bad. Request for member C string and value std. What? Char values, value underscore string. Then we do switch of value. No return statement. Oh, well, yeah, okay, fine. That's fair enough. I should have a return statement at least. Okay, maybe I was just looking at previous error messages. Thanks for that. I was unclear that I didn't know that you could switch on chars. That's good to know. Thanks for that. Let's see. Guess keeping it simple confirms my bias. I guess so. Okay. So that means we have the ability to apply our functions and get a new set of points. So what are we going to do here? So we can iterate through. And I guess what I need to do is I need to test to make sure that this apply trite thing actually works the way we expect it to work. So let me just... well, maybe we can just go ahead and start doing the visualization, like assuming that it works. Let me think. I kind of feel like, and I know this might be a bit weird, but I kind of feel like this might be a good place to stop, actually, because the next thing I do is probably going to take over 20 minutes, and that's about how much time I have left in today's stream. This is a good stopping point. So we have all the functions and everything written in such a way that we can now do this upcoming visualization. And I think this is a good place to stop, honestly. Let me see who's live and who we might want to raid. Bernie Sanders is live. Lana Lux is live. Loading Artist, Skylius, Strager. I don't even remember Strager. I should remember. Installing Arch. Oh, that's a thing. I feel like maybe we should raid him if he's installing Arch. Okay, that's what we'll do. We're going to go ahead and close stream for the day, guys. I think this is a good place to stop. I realized today was a bit short, but, you know, I'm a bit shot, so I think this is fine. So tomorrow we will finally get this visualization up and running. It'll take a bit longer than 20 minutes, but I'm really happy with how this is turning out, so I'm pretty happy with that. Let's go ahead and raid Strager because he's, you know, installing Arch. So let's go ahead and start the raid on Strager. Oh. Cool. Thank you guys so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whenever time it happens to be your time. And I will see you guys around next time for the next episode of Simuleos, where we actually do this upcoming visualization. Pretty happy with it. I'm really happy with the progress we made today. By the way, Bazooka Puka, thank you so much for following. And that is it for now. I'll see you next time. Bye, guys. Nope.